So I wanted to share this project I did a while ago about model-based machine learning, and it's called Uncluttering Your Inbox. The project is essentially inspired from a book called Model-Based Machine Learning from Microsoft, and an example in the book that has the same title called Uncluttering Your Inbox. The example, the chapter 4 here in the book goes in detail about how to build this model-based machine learning and how to make the model more sophisticated, and it actually contains a lot of very good explanation. And most of the work that I've done is based on the example and their explanation. So a lot of credit goes to the authors of the book. And also I tried to kind of build some research questions to try to extend the models described in the book. So you can see here the research questions I had is that how can I extend the model described in the book to use the email body? Because the model described in the book does not use the email body, because the email body, as you know, is a sensitive information, and the dataset that they have collected, it does not contain the email body. And also I tried to extend the model to see how I can build a hierarchical one to better model the personalized choices of individuals. So the first challenge I ran into in how to find a dataset that contains email bodies. And after some research online, I found this database called Enron email dataset. It contains a lot of raw emails of the employees of the Enron company. It's about 1.7 gigabyte, and then I had to pre-process that to prepare it for the project. You will find all of the pre-processing code, which is essentially just three Python scripts here that pre-process the dataset, and then after pre-processing, you can save the process data, and then we can load them in the notebook. Once the data is processed, they will be stored in pickle files here for every individual, as well as the dictionary that we will generate from these emails. So back to the notebook. In the notebook, you can see here just briefly, I will explain how I model every person with a short name, name, and also the emails, and every email with with the email stated in the to field and the CC, BCC, and then the subject of the email, and then the body. And then, of course, a lot of pre-processing is done to kind of prepare the data for topic modeling, because I will use topic modeling in order to enrich the models. And a lot of tools, I've used a lot of tools to do this stop word removal and also the lemmatization and so on. As you can see here, I use the natural language toolkit for doing the stop word removal, and I used Spacey for doing the lemmatization. And of course, the probabilistic machine learning models are created with Pyro. And Pyro is, as you can see here, is a universal probabilistic programming language written in Python and supported by PyTorch. It's essentially an API in Python that you can use. And it's actually very nice that it has PyTorch as a backend, because you can mix probabilistic models and deep learning models together. Okay, so the setup part of the notebook starts by installing some packages and prerequisites for, as you can see, Pyro and NLTK and Spacey and so on. And then after that, I will mount the Google Drive, because I'm loading the pre-processed files from my Google Drive as I'm using Colab, so it's easier to do that. If you are loading them locally, then you can enable the other option. And then after doing so, I will import some Python packages and then start loading the pre-processed data. As you can see here, when loading the data, I can specify the individuals for whom I want to load the data, because those names correspond to the files here. So I can say, okay, I want to load only 10, not all of them, for example. Anyway, after loading the data, you can notice here I loaded 32 individuals and a total of around 10,000 emails, because we need quite a lot of data to train these models. Then I will start preparing the data frame, because we want to put everything in a data frame, which make it easier for us to start the training and testing processes. And here also is where we start adding the engineered features, because as I said earlier, in the example in the book, they kind of design a feature set, and I have chosen some of the features they have done, not all of them, and some of the features that I have chosen are actually the position of the user's email on the to list and the CC list. So the idea is very simple. If the user is mentioned first on the to list, then this will give us an indication that the email is targeted to him and that it might most likely not represent clutter as if the user, for example, was mentioned on the CC list, but even to the end of the CC list. So this is kind of the feature that this set of features tries to capture. So as you can see here, I do some basic code to build the pandas data frame, and then this once we do this, we get our initial data frame. So every line here represents email, and I mentioned some information about the user to whom the email belongs, and also the subject, the process body, the bag of word body of the email, the subject length, body length, and also the designed feature set. Whether the user is not mentioned at all on the to or CC lines, then maybe he is in the BCC, or maybe he is the first on the to line, or second on the to line, or third or later, or first on the CC line, or second or later on the CC line. And here is our target label. This section adds more engineered features, so inspired from the feature set designed in the book, we also add the features that represents the bins of the body length and the subject length, because we will use them as features instead, or at least to compare them with using the raw value of the body length and the subject length. So you can see here that I'm creating some bins for the body length, and in the next section I'm creating some bins for the subject length, and this will give us some more features to add to our dataset. And so once all of these features are added to the dataset, you will notice that now we have more features because we have created the bins in which the body length fall in or the subject length fall in. So before start building the models, I will prepare the topic modeling. And in order to do that, we need the bag of words for every email. And so I'm going to load, because I've already done that when pre-processing the data, I'm going to load all of that from the process data, but I'm just going to reform them and put them in proper arrays and so on. And then you can see here I've actually tried to do topic modeling with Pyro with an latent Dirichlet allocation model. But it did not work for me. It kept timing out while doing training, and I'm not really sure why that happened. I suspect it is because of the large vocabulary size, but I'm not really sure. You can try for yourself, maybe fix a bug or something and see why it didn't work for me. But you can see the model is here, and I put the latent Dirichlet allocation model that I've tried to use to model the topics in the emails here, and it worked for me a little bit to train. It did not throw an exception or something, but it timed out every time I used I think 10 or more documents or something like this. So you can see the models here. I kept it for completeness, not because it is working. Then because it didn't work, I tried to use Gensim, and modeling with Gensim was pretty much straightforward. I just create the Gensim model and feed it the data that I have, and then I get the topics, as you can see here. It will create these topics. I've chosen 15 topics in total to model the topics of every email. And once that is done, I will also add the topics to the data frame. So I have 15 topics, and this means I need to add 15 new features to the dataset. I put everything together here, and you can see on top of our designed feature set, now we have also 15 feature that represents the topics of every email, and then I will save everything, then we can easily load it later. Okay, now I start building the classifiers, and I will start with the simple classifiers just to compare what will happen when I add different features or when I use hierarchical models, for example, versus simple classifiers. So here I start with simple classification, and I would show you here, I of course split the data set between train and test, and I start with classifier, what I call it 101, where I will use the body length, the numeric features directly, not the bins, and the subject length, and also the to and CC position features. And this is the probabilistic graphical model for this simple, very simple model. These are the model parameters, the alpha and beta, and this is the target label, and those are the input features that I'm going to use. So I prepare here the training set and also the test set, and then I create here a baseline model using um, an off-the-shelf model, logistic regression from scikit-learn, and I get an accuracy of 52% just to test it against my model that is developed in Pyro. Here is my Pyro model, and then I will prepare the data for Pyro because Pyro will accept tensors, PyTorch tensors, so we need to convert the data to tensors. And then I will define the guide function for the training and so on. And then when I do the prediction, I will get almost 50%. It performed a little bit less than the baseline model, but at least it's kind of very similar. And we can see this model is not really very much effective when using the row length and the row uh, when using the row body length and the row subject length. So I tried with another classifier, called it 102, and here I will use the body length bins. So it's not the row number itself, but just the bins that I've created, and also the subject bins I've done the same, and then I use the two CC position features. And you can see it's the same model, the target feature, uh, the model parameters and so on. And then I will prepare the test and train data set just I've done before. And this is the baseline model also, the logistic regression, the same one that I used before from scikit-learn. And you can see we immediately have a better accuracy of 58%. And now this is also our Pyro model. It's essentially the same as the one before. And when training, this will give us 57%, essentially the same value, 58%. So we have increased the accuracy a little bit from the previous one. Now I try to move to another classifier. I call it 103, where here I will start adding the topics. So I will add the topics features along with the subject length bins and body length bins and also the 2cc position. This model, once everything is prepared, as you can see here in the baseline model, it is also 58. It's kind of the same as the one before it. And also the one that is done with Pyro is 58. So we haven't really increased that much by adding the topics. We have done a step when we moved from the row numbers of the subject length and body length to the bins. But when adding the topics, we haven't really increased that much. And then I moved to this hierarchical classification to better model the personalized choices of, because what could be considered clutter for one user, it might not be considered clutter for another user. So then I started, because in order to do this with Pyro, we would need to add a unique number to identify every individual and so on. So I just added a column here that adds a unique number for every individual. As you can see here, Sally got the number 1, for example, Baz got the number 2, and so on. And then I split the data in train and test. And then I will start with the 201. So this is classifier where there is a hierarchical model, but it's still my first shot. So I will use the body length bins and the subject length bins and also the 2cc position with a hierarchical model. So here without the topics. And you can see here, I'm going to use the alpha model parameter, but it is now not shared between all the users. It is specific to every user will get his own alpha parameter. Great. Now I will split the data in train, test, build the hierarchical model. You can see the Pyro model here and take a look at it. And I will prepare it and so on. And I think here where I start training it and get the posterior distribution. And so once I get the predictions, you can see it is now 64%. So we have actually achieved an improvement over the previous model by introducing the hierarchical concept into the model and not just sharing the alpha parameter between all the users as we've done previously. Great. Now I did the same model, but I just added the topics to see also the effect of these topics. So it's the same as the previous model, just I added the topics. And then you can see when preparing the model and training it and getting the posterior distribution and so on. And as you can see, the accuracy hasn't really increased that much. So apparently adding the topics hasn't contributed much to the results. You can see here the comparison between all the models that I've done. These two last models is where we have introduced hierarchical, and you can see there is a very good step between these two, and these two is where we moved from the row body and subject length to the bind features, and we have also increased a step here. But between this one and this one, and between this one and this one, where we have added the topic features, there is barely noticeable increase in the accuracy. This could be because of bad topic modelings for the email bodies, or maybe because of the pre-processing, or it could be because the email body has not contributed that much, which I will doubt. So I will say there is some issue here that could be investigated, and then where these models could be improved over the ones that exist now.